You expect a splash. Because that's what always happens. But what if it didn't? What if it bounced instead? This looks impossible. But it's pure physics. Normally, water spreads instantly. It collapses into a splash. But this surface changes everything. Water can't stick. It holds together. Storing energy inside. Then releasing it back. That's why it bounces. Now watch carefully. This moment lasts less than a millisecond. It touches, but doesn't collapse. Instead, it compresses. Holding all its energy inside at maximum compression. It starts to recover. Surface tension pulls it back. And then it leaves the surface. No splash. No breakup. Just a perfect rebound. And it can happen again. But why does this happen at the exact moment of contact? The drop begins to flatten. Like a compressed spring. Storing energy inside. But the surface rejects the water. So it can't spread. Instead, it pulls itself back together. Driven by surface tension. Releasing all that stored energy. And that's the balance. A perfect energy transfer. But we can push this even further. But what happens if we change the conditions?
What if two drops interact?
They collide and break expectations. Liquid behaves like something alive. Sometimes it even splits apart. Creating unpredictable motion. What if the drop is bigger? The bounce becomes unstable. Smaller drops behave differently. Faster, and more elastic. What if the angle changes?
It starts to move unpredictably.
Even rotation appears.
What if the surface isn't perfect?
The motion breaks symmetry and becomes chaotic. Every tiny change creates a new outcome. But the physics stays the same. The drop stores energy. Then releases it back. Surface tension pulls it together. And the surface refuses to absorb it. That's the only difference. Change the surface. And you change the outcome. Even small details matter. And physics makes it all predictable. But this isn't the only way water can behave. Under different conditions, everything starts to change. The same drop. Can behave in a completely unexpected way. Sometimes it doesn't bounce at all. It does something far stranger. And you can't predict it at first glance. But there's a reason behind it. And we'll show it next. Subscribe to see what happens next. Because the next experiment breaks everything you just saw.